Welcome to the first webcast in this year's Arc Flash University series, Arc Flash University, a checkup on your electrical safety program. Thank you for joining us. I'm your moderator, Peter Wielander, and I'm happy to join you today on behalf of Plant Engineering. I'm happy now to introduce today's distinguished speaker. Lanny Floyd retired from DuPont in 2014 after a career spanning 45-plus years. For over 30 years, his responsibilities focused on electrical safety in the construction, operation, and maintenance of DuPont facilities worldwide. As a principal consultant, electrical safety technology, he was responsible for improving management systems, competency renewal, work practices, and the application of technologies critical to electrical safety performance in all DuPont operations, and the application of his knowledge and his experience to electrical safety products DuPont brings to the marketplace. He is an IEEE Life Fellow, a professional member of the American Society of Safety Engineers, a certified safety professional, a certified electrical safety compliance professional, a certified maintenance and reliability professional, a certified reliability leader, and a registered professional engineer in Delaware. He has authored or co-authored more than 70 published papers and articles on electrical safety. He is currently Principal Consultant and Partner, Electrical Safety Group, Inc., Adjunct Professor of Advanced Safety Engineering and Management, University of Alabama at Birmingham, and Editor-in-Chief, IEEE Industry Applications Magazine. I'm Peter Wielander, Webcast Moderator on behalf of Plant Engineering. So Lanny, take us out.
Well, thank you, Peter, and I want to also thank the team at Plant Engineering and our sponsor, Littlekeys, for helping make this event possible. I'd like to expand a little bit about my background. Peter gave you an overview of my work, but as he noted, I had a 45-year career with DuPont. I retired in December 2014. 30 of those years, my focus was primarily on improving the electrical safety management systems that we had in our global operations in DuPont for our facilities around the world. In 2013, I joined the faculty at the University of Alabama at Birmingham in the graduate program of Advanced Safety Engineering and Management. As Peter noted, I have a number of credentials, certifications, et cetera. All of those are related to the work that I've been trying to do in advancing the practice of electrical safety. Now, with all that, the papers I've written and the certification I've gotten and all that, what I am most proud of is the demonstrated results that we were able to achieve in DuPont in advancing the practice of electrical safety, in particular impacting the likelihood of fatality from contact with electrical energy. This chart is showing the DuPont electrical safety performance fatality from electrical contact from 1940 to the present. And you can see there in the middle, that's the period of time when I joined DuPont, and during the 1970s and 80s, early 90s, the company was experiencing one electrocution fatality every 33 months. Now, DuPont was a global leader in safety and process safety throughout the 20th century. Its history of DuPont was as a manufacturer of explosives and hazardous chemicals. Now, although DuPont was a leader in safety overall, what we realized that when we looked specifically at the electrical hazard, we were no better than industry average. That one fatality every 33 months for a workforce of 100,000 people was about industry average. We believe that we can make a difference. We set out to change the electrical safety culture in our organization. We engaged management differently than we'd ever done before, engaged our workforce differently than we'd ever done before. And you can see in this chart, we were able to achieve breakthrough performance in preventing fatalities from electrical contact. DuPont has now gone over 22 years without an electrocution fatality involving its employees or contractors working in facilities around the world. Now, I'd like to emphasize we did not eliminate electrical fatalities. we reduced the likelihood, and we increased the mean time between events, hopefully for a very, very much longer time. But one of the things that helped drive this culture was the realization that no matter how good you are in preventing electrical injuries, a fatality could occur today. And so that's part of what drove that continuous improvement in that culture. Now, looking at our next slide here, as again, some additional background on that. Again, DuPont was a global company with more than 150 manufacturing locations around the world and operating in 80 countries. So this performance was more than just in North America or in the United States. It involved working environments around the world where code, standards, regulations vary somewhat. But again, we had a very strong culture driving that internally within our company. Now, what this chart shows is that it is possible to make a big difference impacting the safety of your workforce with the exposure to electrical hazards. So what I'd like to talk about very briefly is, why did I get involved in this? You know, what prompted me to get engaged in my work in trying to advance the electrical safety culture? Well, going back in the early part of my career, the first 10 years or so, you see here some personal experiences. 1 month after I joined DuPont, we had an electrocution fatality, and that impacted me. I'll never forget that. It was going to work for one of the world's safest companies, and then a month later, we're in a meeting discussing this electrocution fatality. In 1982, I was involved in a mishap involving one of my coworkers, someone who was a mentor and work colleague and a friend, and something unexpected happened, and he came in contact with 480 volts, actually 277 volts to ground, and was electrocuted. I was the first responder to that. I was close by with him. I attempted to save his life with CPR, but that was not successful. He died. 9 months later, I received a call that we'd had another arc flash injury at one of our plants. And the next comment on the call was that, it's your father. My dad was an electrician working for DuPont, so in 1983 he was involved in an arc flash event. Although he recovered from those injuries, he never worked again as an electrician. In 1987, an uncle, one of my uncles, was involved in an arc flash event where he received second and third degree burns over 90% of his body. The burn center said that he had a 1 chance out of 100 for surviving that event. He was very fortunate in one respect. He did survive that injury. He was in the hospital for over 3 months. He suffered rather severe permanent disabling injuries, and but he was discharged from the hospital, and he then proceeded to have a continuing experience of going to hospital with further rehabilitation and treatments and surgeries and so forth. This is very devastating to the family, very stressful to the family. And a couple months after he was discharged from the hospital, my aunt suffered a massive heart attack and died. She was 52. And that event really impressed upon me the impact that these injuries have on families and loved ones. But these events in total had a very impactful force that shaped my career for the following, continuing today. And so for the past more than 30 years, I've spent a great deal of my time examining, studying, and searching, exploring the nooks and crannies of regulations, codes, standards, safe work practices, technology, PPE, you name it, of how we could improve those capabilities to prevent these mishaps from occurring. Now, most people, when you think about electrical safety in the workplace, they tend to focus on the code, standards, regulations, and that's what I've shown here in this slide. You can see the OSHA regulation. There's the National Electrical Safety Code, which is directed primarily toward the utilities, the National Electrical Code guiding the installation practices, the NFPA 70, very prominent standard in workplace safety. Also showing two of the Canadian standards in this collage here. There's the Canadian UL code, which is equivalent to the National Electrical Safety Code in the United States. And also that standard cover in the lower left is the CSA Z462, which is the Canadian standard for workplace electrical safety. Now, what this is pointing out here is that the electrical safety regulations and standards are just part of the solution to preventing electrical injuries in the workplace. What I have found in my work over the past 30 years is that achieving excellence in electrical safety lies in understanding what is not in the electrical safety standards. Now, these topics that I have around what I call the white space around these codes and regulations, these are some of the topics that the more you understand these topics, the more you study these topics, the more effective you can achieve in the implementation of the code, standards, and regulations. Now, in my work at the University of Alabama in the graduate program, I teach on these topics that are in the white space. That's what I talk about in my course on electrical system safety. So certainly, the codes and standards are at the core, but again, what I'm trying to help people understand is the leveraging effect and the catalyst effect that understanding these other topics have. Now today, I'm going to talk about three of these. I've got the bright red borders around NFPA 70E, and we'll talk a little bit about that. I'm going to talk about the illusion, what I call the illusion of control, and also the business case. We don't have time to talk about all of these topics, and we don't have time to talk about those three in great detail, but hopefully I can convey some thoughts and ideas that can help stimulate your own thinking about how you can bring improvement in your organization or wherever you may be. So first, let's talk about the business case. Now, I borrowed this definition from a military standard. It's Military Standard 882E, the standard practice for system safety. This is the definition in the standard for the term mishap. I like this definition because it expands, helps us understand the total business value in preventing an electrical incident. Now, this military standard is broader than, it's not just for electrical safety. Let me point that out. This is how, this is a guidance on managing risk for all safety-related hazards. It was developed, I'll talk about that in a moment, where its background. But this definition for mishap is an event or series of events resulting in unintentional death, injury, occupational illness, damage to or loss of equipment or property, or damage to the environment. And so when we think of what is the business value for preventing an electrical incident or an electrical mishap, we can use that to help us understand, well, what is the goal of our electrical safety program? Is the goal to prevent injuries from electrical energy? That could be one goal. But I think the bigger goal, the one that brings the most value to most organizations, is the one that I have checked here. The goal is to anticipate and prevent mishaps in electrical systems that are critical to your business. And they may be in the energy systems, or it could be in the control systems, or in the communication systems. So think about it for a moment. What are the potential consequences of mishaps in the electrical systems in your work environment? certainly probably at the top of the list is the prevention of serious injury. But again, reflecting back to that definition of mishap from Military Standard 882E, it includes damage to critical equipment, disruption in production or services, process safety implications if you're operating a highly hazardous manufacturing or other type of operation, fires and explosions, project delays if you have a mishap involving critical electrical equipment and if equipment is damaged. You may have project delays if you're involved in capital programs. It could impact product quality if your customers, if the loss of electricity, either in energy or control, impacts product quality. That could have an impact on your relationship with customers. Depending on the type of industry or business you're in, there may be other consequences. So my suggestion is that you take some time and think about what is the business case? Why do we want to improve our electrical safety program in our operations? It's more than the prevention of injury because the injuries, as we'll see in a few minutes, are relatively rare. But these other consequences can happen much more frequently. And the effort that you put into preventing injury can also contribute to preventing these other undesirable consequences of a mishap in electrical systems. So let's change gears here a little bit. We'll talk about what were some of the changes in the 2015 revision to NFPA 70E. Now there is a revision currently underway that will be published as the 2018 revision. The NFPA 70 Technical Committee is still doing its work to evaluate the suggestions and comments on changes that are being proposed for 2015. They'll be meeting later this summer to finalize the discussions and selection of the changes that will be included in 2018. So I'm not going to talk a great deal about what's coming up in 2018 because I think it's a little premature. But if you look back at the changes that were made in 2015, if you have a copy of the standard, the changes are summarized in the forward. That's on pages 3 and 4 of the 2015 edition. And I'm not going to go into great detail on those, but there was one very significant change in the 2015 edition of the standard that will continue with additional changes and refinements in the 2018 edition. And that is, how do you measure risk? And how do you identify risk from potential contact with electrical energy? Here's what's out of the 2015 forward of the standard, and it said this: the 2015 edition of NFPA 70E reflects a major shift in how stakeholders evaluate electrical risk. What this is attempting to do is to help you change how you think about managing electrical safety in a way that helps you be more conscious of the potential consequences, what can go wrong, what can happen, and the measures you take to prevent those bad things from happening. Let's take a look a little bit more detail on that. Now, in Article 110.7, it's addressing the electrical safety program. Now, I'm not including the entire text out of that, but there are 2 informational notes. The first informational note says that safety-related work practices are just one component of an overall electrical safety program. Now, until the 2009 edition, that's the only statement that it made there. And what it was really emphasizing is that NFPA 70E is primarily safety-related work practices. And what this informational note was emphasizing is that everything in NFPA 70E is just one part of the overall electrical safety program, and it really didn't answer the question, well, what are the other parts? Well, in 2009, the informational note 2, as shown here, it was taken out of the 2012 edition, says that ANSI Z10, the American National Standard for Occupational Safety and Health Management Systems, provides a framework for establishing a comprehensive electrical safety program as a component of an employer's occupational safety and health program. Now, the significance of that is that ANSI Z10 is part of a family, or not really a family, but is an example of some widely recognized occupational safety and health management standards. And this is the first time that it was linked in to 70E. Now, this slide shows two things at the top. Over on the right-hand side at the top, there's a little word collage, and it's centered around the concept of risk management. And each of those words in there has something in there related to what risk management is about. It's kind of a word cloud emphasizing risk management. That's a big part of occupational safety and health management system standards. Over in the top left is what we call the hierarchy of controls. That is also a key component of safety management system standards. We'll go into that in just more detail in a few minutes. Now, along the bottom is a timeline of the development of safety management system standards. These kind of grew out of the early 1940s, just before World War II, when the concept of system safety evolved. And system safety is about identifying potential risk and taking necessary measures to mitigate that before the accident happens, before the event happens. Now, if you think about what was going on at the time, this was in the early development of nuclear power and nuclear weapons. System safety was developed as part of the ways to manage the risk of that evolving technology. Aviation was expanding and growing by leaps and bounds on the complexity and the power of military aviation. So the ability to prevent a mishap from occurring from these technologies that were evolving around just before and during World War II played a very significant role in the development of safety management system standards. I mentioned Military Standard 882 a few moments ago. That was the first documentation of system safety methodology. That was published in 1969. In 1999, OSAS 18001, which is a European standard, was published as the first, I'll call it a commercial safety management standard as compared to the military standard. Excuse me. And that OSAS 18001 today is probably one of the most widely used occupational safety and health management system standard around the world. In 2005, ANSI Z10 was published. And that's the standard that NFPA 70E refers back to in that Article 110.7 that I just reviewed. In 2006, CSA Z1000 was published. Later this year, ISO is publishing their standard 45001. Now, all of those standards are in the family of occupational safety and health management system standards. They're very similar. They have some commonality, and in particular, the commonality around the two items that I've noted here at the top of the slide. Now, in 2015, NFPA 70E has expanded the methodology that comes out of the safety management system standards, in particular the concept of risk management, and the expansion of discussion of the hierarchy of controls. So that was a very significant change in 2015. I'm not sure how many people are paying attention to that, but that's something that, in my experience, is probably some of the most powerful tools in FPA 7E to significantly change the electrical safety culture in an organization and put in place the system to assure sustainable, continuous improvement that is aligned with preventing the mishap from occurring and not just protecting people with more PPE. I don't want to suggest that PPE is not necessary. That's not it at all. But PPE does not prevent the mishap. PPE prevents injury. A big part of risk management is about getting in there, doing the work necessary to make sure that the mishap never happens in the first place. Okay. Now, to help with that, in the 2015 edition of 7E was the informative Annex F, titled Risk Assessment Procedure. It was an expansion of something that was already in there, but a lot of work was done. Some very talented people that are knowledgeable in risk assessment were involved in helping refine Annex F so that it's a more useful document. Now, it's a 9-page annex, and I'll just make a comment that you don't become an expert in risk assessment just by reading these 9 pages. But the 9-page annex provides guidance regarding an approach on risk assessment that includes hazard identification, risk estimation, risk evaluation, risk reduction. It basically asks, helps you answer these 4 questions. What can go wrong? And in particular, what can go wrong that could enable someone to contact a source greater than 50 volts AC or have someone exposed to an arc flash. Those are 2 things that can go wrong. And then it helps you understand, well, what are the potential consequences? Is death possible? Is permanent disabling injury possible? Or are there other consequences that also that could be possible? It's important. I think a lot of times people don't really think about what's the potential consequences. We get so used to working in and around electrical equipment that we may forget how severe these consequences can be. And it asks the question, well, what is the likelihood something could go wrong? Could it be frequent? Is it probable? Maybe occasionally something go wrong? Maybe there's a remote chance? Or is it absolutely improbable that something could go wrong? This helps assess the severity of the exposure and the frequency of the exposure. And then lastly, what controls can reduce the likelihood or severity of these exposures? Now, that's where the hierarchy of risk controls can come in. This is a simple illustration of the hierarchy of control measures. ANSI Z10 and the other occupational safety health standards go into detail on doing this. This is a core competency in the safety professional discipline. Now, a very useful resource for you, and it's free, is if you go to the URL that I've noted there, or search for the OSHA e-tool, which means the electronic tool, on hazard prevention and control. There's a several-page guide there on how to think about applying the hierarchy of control measures. That's free. Again, it won't make you an expert at this, but it helps you get a feel for what this is about and how to use it. Now, another resource that I'll mention here, and this goes into great detail. The American Society of Safety Engineers has established the Risk Assessment Institute. Again, this is not unique about electrical safety. This is about risk in a very broad context. But they have a certificate program that's a 40-hour continuing education program that includes classroom, it includes some other work, and there's some actual a project that has to be completed in order to get their certificate. But this is one of the most comprehensive educational opportunities to understand how to do risk assessment really well. And some organizations that may find this useful. Some may find it more than they can doesn't fit their program. But again, my point on this is that the concept of risk assessment is being built into 70E. It's already there, and the 2018 revision will continue emphasizing that concept. And so getting really good at that is one of the keys of really embracing 70E and getting really good at effective implementation of the safe work practices that are in the standard. Last thing I want to talk about is what I call the illusion of control. There are 3 points here on this that I'd like to touch on. Who is at risk? The low frequency of electrical injuries, and the residual risk associated with lockout, tagout, or you can also refer to it as the creation of an electrically safe work condition. The risk for electrical injury shows up in 3 different ways. If you look at the OSHA Bureau of Labor Statistics data, what this chart is showing is that about 45% of the electrical fatalities, looking at the period at 92 to 2010, were due to contact with overhead power lines. Most of those were not electricians or linemen. These were other workers who were either carrying conductive equipment, ladders, pipe, guttering, whatever, material handling, unloading trucks near overhead power lines that came in contact. In the middle group there is the contact with wiring, transformers, and other electrical components, about 30%. That's the work activity that you typically associate with electricians. They're taking covers off. They're working inside equipment. They're installing the electrical equipment. And then the third area there at the bottom, the third line, is contact with electrical current and machine tools and appliances. This is people using portable tools, using portable appliances, and again, that covers a lot of people. Almost everybody in your organization, in most work environments, have the opportunity to come in contact with tools and appliances, and if there's a defect in that tool or appliance, then you could have an electric shock situation. That's about 15% of the fatalities. So your electrical safety program needs to address all 3. Now, see, for example, lockout, tagout doesn't apply to the bottom one. So you got to make sure that you have programs in place to address the specific scenario. Contact with overhead power lines. I mentioned that it's not just lineman and electrician. Now, in the upper left, we do see linemen working on overhead power lines, but in the other photos in this collage, we see cranes, dump trucks with the beds up. We see rolling scaffolds. We see people working on a roof. Excuse me. We see people with an aluminum ladder. Again, these things, if they contact an overhead power line, can result in a very tragic electrocution. Excuse me, I had to cough there. And so part of the illusion of control around this aspect is that it's not just electricians and linemen. If your electrical safety program, you need to make sure it's embracing other people who could come in contact with overhead power lines. Now, at the contact with electrical components, as you see in this collage, this was that middle group of electrical fatalities that was about 30% of the total. You can see these are obviously people working in and around electrical equipment. They're doing maintenance, hooking up wires, troubleshooting, whatever. That's where 70E puts a lot of its emphasis, is people working on or near electrical equipment. Then we have the third category that I showed in the chart. That's contact with machine tools, appliances, or light fixtures. And so we see appliances, we see control panels there in the lower left with certainly there's electrical wiring, electrical energy inside that panel. If that panel cabinet is not grounded properly and we have a failure inside, we can have an energized panel. The photo there in the center is a construction worker using an electrically powered tool. We see vending machines in the upper right. If there's a failure in the insulation systems and it's not grounded properly, or if we're not on a GFCI, we could have people just using the vending machines being subject to an electric shock or electrocution. In the lower right, we see someone in a healthcare environment. Again, these are tools and appliances powered by electricity, and if they're not maintained and grounded and safeguards used, we could have hazard to not only the technician or the nurse or the doctor operating it, but the patient as well. It's not just lockout tagout. If your focus of your electrical safety program is on lockout tagout, you may be overlooking some of the other exposures. Right? We have certain work, as illustrated in the left, that is linemen that are using standard procedures and working with rubber insulating equipment. We have the worker with the electrically powered tool. Again, lockout tagout is not an effective control for that type of exposure. And we have a person doing diagnostic testing on energized systems, and again, lockout tagout is not an effective solution there. It's not just arc flash. This chart is from some work from NIOSH. You can see in this slide we have various industry segments, from construction at the top down to manufacturing, utilities, on down to other industry segments. And you can see the section of the bar that is shaded in gray. These are electric shock injuries, and these are all non-fatal in this chart. And the solid white part of the bar is electrical burn injuries. So electric shock injuries is more than half of all of the electrical injuries reported in this time period. So if arc flash got your attention, make sure that you pay attention to the rest of NFPA 70 that talks about the prevention of electric shock, because electric shock is the big killer in electrical accidents. More than 90% of the fatalities from electrical energy are related to electric shock. Arc flash causes a lot of bad injuries and damages a lot of equipment. And compared to electric shock, there are relatively few fatalities from the arc flash. It's not just electricians. Don't be caught by the illusion that your electrical safety program is focused on your electricians, because about half of the electrocutions in the United States occur to other workers. You can see here in the upper left, the top occupations having the most electrocution deaths. Electricians and linemen comprise about half, but then we have construction laborers, managers, truck drivers, agricultural workers, roofers, painters, carpenters, landscapers, the other 50%. Our own experience in DuPont, when I was working with DuPont, 7 out of the 12 electrocution fatalities we had from 1968 to 2011 were not electrical workers. So you need to make sure your electrical safety program extends to all people exposed to electrical hazards in your workplace. Another part of trap with the illusion of control is that electrical injuries are very rare. This pie chart shows all of the lost time injuries in the United States in 2010. There were about 1.2 million injuries in 2010. And the number of lost time non-fatal injuries from electrical shock and burn, you can almost not see it here, It's a very, very tiny sliver of red at the 12 o'clock position on this chart. What this means is that electrical injuries are relatively rare compared to other injuries in the workplace. And they can create an illusion that we don't have a problem. We haven't had any electrical injuries, therefore our program must be good. Unfortunately, that may not be true. The reason that you may not have had any electrical injuries is because the electrical injuries just don't happen very often. It may have nothing to do with the quality of your program. You really have to focus on the other aspects of your program, and not just the fact that you haven't had any electrical injuries. The high consequences are noted over here on the lower right. 1 in 13 lost time injuries from electrical contact is fatal. Extremely high severity of potential outcome. Currently, it's the 7th leading cause of occupational fatality in the United States, even though the injuries don't happen very often. Because of the high severity, they have their leading cause of fatality. And insurance companies have reported that electrical injuries are their second most costly workers' compensation claim, especially the ones involving long hospitalization stays and long recovery or rehabilitation. Also, the other aspect of the illusion of control is around lockout tagout is that there are spatial and time boundaries associated with that lockout. Let me show the next slide here, and that'll illustrate it. You can see in this photograph, this is a lineup of electrical switchgear, and the unit that's second from the right has a green sign on it saying under high voltage permit. That compartment is in an electrically safe working condition. However, the compartments on either side and the compartment above it, the main bus compartment, are still energized. So the residual risk of this electrically safe work condition is making sure that people stay inside that work zone. They don't take a cover off. They don't drill through the side. They don't put a screw through a hole without analyzing the risk of doing that. There's also the time associated. And here we're showing that the shutdown is from 8 o'clock Tuesday to noon Friday. And so part of the residual risk is making sure that people stay within that time boundary. And I've seen a number of tragic scenarios where that didn't happen. Okay. A few more, just some resources available to you that can be very useful. NFPA last March published a year ago an analysis of the occupational injuries from electric shock and arc flash events. That's available free from the NFPA Fire Research Foundation. You can just search for that, NFPA Fire Research Electrical Injury Report. Also, ESFI, the Electrical Safety Foundation International, has data on its website that's free on injuries, trends, analysis, that sort of thing. Speaking of ESFI, ESFI sponsors the National Electrical Safety Month, which during the month of May. Their resource kit for the 2016 Electrical Safety Month is available for a free download. Great resource for awareness that's available to you. And okay, these are the three things I talked about today: the illusion of control, a little bit about NFPA 70E, a little bit about developing the business case. I'd like to leave you with this thought: you only see what you know. And again, going back to my work, I've made it my life's work in my career to try to see more, to expand the envelope of what is critical in managing electrical safety, just so that we can have a bigger impact on reducing that risk. This is my last slide. That's my contact information if anybody wants to reach me for further discussion. So now I'd like to turn it back to Peter. Peter?
All right. Thanks, Lanny. The audience listening live can type questions for today's presenter in the Ask a Question box on the screen. We'll get to as many as we can. Within a few days, this presentation will be available for on-demand viewing. We'll post an archive on the Plant Engineering website, and we'll send you an email message with a link connecting directly to it and to related resources after it's ready. As a reminder, take the Learning Unit exam. Use the Learning Unit exam tab option at the top of your screen. The exam will be open in a new browser window. You can complete the exam after the webcast. However, the link will break when the webcast signs off. The exam will be posted on the Plant Engineering website with the on-demand version of this webcast. So let's take a look at the questions now. A couple things have come in about, you're talking about safety culture. You made a mention at the beginning that you can only really extend the time between mishaps. The nature of the threat never completely goes away. So how do you get people to act that way? Is it do you have to get them to start thinking in terms of a safety first or a think before you act approach? Is it weekly safety meetings? What are the keys to getting that kind of safety cultural change?
Well, Peter, I think that there's no one single magic bullet other than to shift the culture in any organization requires top management leadership support that establish it as an objective of the organization. You need that for long-term sustainability of your improvement process because any improvement initiative on almost any topic that's crucial to a business involves resources of money or people to make those things happen. And so that's why a culture shift starts at the top. Now, that doesn't mean that the workers at the bottom aren't critical to educate management about what is important. That's certainly true too. But having strong management support is absolutely critical. That's why I emphasize the business case here, Peter.
Right.
I think the more that management and the whole organization understands what is the total value of this effort, then the electrical safety program may shift from being a cost to a value creator for an organization.
Do you like the idea of the regular safety meetings? Is that helpful?
Safety meetings are important. If they truly engage workers and supervision and management, it's not just a one-way communication, but the more you can engage the workforce in understanding what their concerns are, what they see the risks are, what they see the hazards are, and what their ideas on making improvements. It's very critical. So safety meetings is part of that process.
All right, let's look at a couple things that are a bit more specific. Can the door of a low voltage panel, less than 600 volts, be open for the purpose of looking inside without having to wear arc flash PPE?
Well, let me give you a little analogy on that. Let's say you're driving your car down the road at 60 miles an hour. Now, the driver is doing the work, holding the steering wheel, whatever, has their seatbelt on. The person beside them in the passenger seat is not doing any work. They're just looking. They still need to wear their seatbelt. In the same way, for that question is that it doesn't matter what you're doing. What matters is there a hazard, and are you exposed to the hazard? So for most equipment that's under 600 volts and above 240 volts, there may be an exposure to an electric arc or contact with electric current that could result in a shock. So PPE should be part of your control measures unless you have analyzed it specifically and determined that it's not necessary. And that would be, for example, for an arc flash event, if you've done the analysis and determined that there is no arc flash hazard, or that you've done a shock hazard analysis and determined that due to the construction of the internal circuitry, there's no likely way to contact a bare exposed part. Then I would say that you may consider that PPE may not be required. But again, unless you've done that work to determine that, my answer to that would be you better be thinking about making sure you have the PPE available and on.
Okay. Here's another one. What are the best practices to validate a qualified person to work on energized circuits and not exclude PP3 and PP4 classified panels? And the situation of doing that in-house as opposed to outsourcing to a contractor.
Let's see. Well, I think that competency around it is a complex thing. It's not just have they been trained on doing something, but have they actually done the work on this particular model of equipment? For example, in a motor control center, there may be, if you look at how many different models and manufacturers and the vintages of motor control centers that are in place in many facilities, it could be a dozen or more. And so when you think about someone who's going to do a task on an energized starter, for example, maybe they're going to, I don't know, do some troubleshooting or something, they're going to open the door. And the question is, has that person ever opened the door on that model, that vintage, that manufacturer? There may be something unique about that that is different. And so you have to look carefully at the task when you think about, well, what skills and qualifications are needed. Again, the hazard is the same no matter what the competency of the person is. The likelihood of an event may change based on the competency, but the PPE required is normally unrelated to the competency of the person. The PPE is based on the hazard and the potential severity consequence. And I think that you really have to look at specific situations to come up with the accurate answer to that question. It's very difficult to have general guidance other than what I just said.
You're connecting the person and the circumstance. Those things have to be taken into consideration together.
Exactly.
Okay. Here's another one about working on energized circuits. Troubleshooting always seems to be a point discussed. Operations doesn't want to de-energize panels because they don't want to lose production. And the second thought is that the panels need to be energized if you're going to do the troubleshooting. So when do you leave things on and work on them that way?
Very good question. Now, 78 addresses this in the discussion of working on or near energized equipment. And for most tasks, there's a requirement that you have an energized work permit. And that work permit is really a planning tool to help you identify the risk, what's likely, what could go wrong, what skills and tools and competencies are needed to do the job safely. Now, 70E also allows for an exemption that if the work is troubleshooting or diagnostic testing, the live work permit may not be required. However, other things have to be in place in order to have the exemption for the live work permit. It has to do, again, with the person's competency, with standard practices that are in place, with the hazard analysis that's been conducted, with PPE that's been selected, and so although the energized work permit may not be required, the level of detail to make sure that the work is being done appropriately is really no different. Now, there are some, the technology is shifting to allow more maintenance to be done in a safer way. For example, the infrared thermography activity. In the past, initially when this was becoming a tool in electrical maintenance, you did have to open doors and remove covers to do the infrared analysis. Today we have the technology with inspection ports and inspection windows that these can be specified either on new equipment or retrofitted into existing facilities so that inspections can be done without opening doors. So Also, things such as smart equipment provide data through communication networks, such as the Ethernet cable, that allow you to do certain troubleshooting from a laptop computer plugged in to the Ethernet, rather than having to open doors and have people in direct exposure to bare energized circuits. So those are some of the trends going on in the world today that reduces the risk through engineering design solutions. So when you're planning new facilities or planning renovation of existing facilities, those are some of the questions that should be asked to see, can we design this for safer maintenance and design it to reduce risk in operations?
Okay, well, thanks for that, but I'm afraid we're out of time, so I don't think we'll be able to get to any more questions. So thanks for what you sent in, and thanks again to our great speaker, Lanny Floyd, for sharing his time and experience.